B2. We knew we had two charges. Actually, I want to do one thing. I want to do one thing first. You guys, there were a lot of people who drew this. So, minus Q plus Q. And you drew this thing like this, and like this, and like this. And well, that's fine. But you guys, remember, you get to choose your coordinate system. You guys get to choose this. What's the only important thing about this is that, well, the two important things, is that you have two identical but opposite sign charges that are separated by a distance d. So why would you want to give yourself a funky thing to look at? Just make it easy, okay? So let's go like this. Let's say we've got plus q, and we've got minus q, and we know this distance here is d, and I'm going to go ahead and draw my, let's go ahead and make that x, y, and I want to know at some point p, what is e of p? Okay, let's see, do I have all the information here? Yes, but let's go ahead and flesh it out just a little. This is x sub p. We're just defining that. X is a value. And then what do we need? What are we asked? We're asked, what is the electric field at this point? So, in order to find the electric field at this point, what's our strategy? It's the simplest strategy possible. We're going to take the electric field of this point and add it to the electric field of this point. And we're done. Okay? So, how do I calculate the electric field at this point? Stop me if you've seen this before, but don't really, because you've seen it many times. Our E, I'll go ahead and call E plus, is going to equal K Q over R squared R hat. Do we know K? Yes. Do we know Q? Yes. Do we know R squared or R hat? No. So all we have left to do for this is just determine our R squared and our R hat, and we'll be done. Okay, so we're going to go ahead and draw that. Let's go ahead and say this is at some angle theta, and and I'm going to go ahead and write this in explicitly, even though it's here implicitly. This distance here is d over 2. So I now know that I have. Let's look right over here. So here's remember, we're at this point, so we're talking about the vector that goes from the charge to the point. So we're looking at the vector in this direction. So I'm going to take this, I hope you guys can see that. I'll take this little triangle right here, and I'm going to go ahead and expand that out. So that triangle is just this. Okay. This is R hat. And it's R hat because I say it's R hat. That's what I'm trying to look at, is the direction of this unit vector. So I just say, I know this is the direction, therefore I am going to make this equal to 1. Make it nice and easy. And then the only question is, this is the y component of R hat. Actually, it's the minus y component of R hat. And this is the x component. No, I already wrote it. This is the x-axis, so therefore this is the x component right here. So r hat is equal to 1, so we're just looking at this triangle, and we're saying that the x over r hat, which is equal to 1, is equal to cosine theta. And we're going to say y, I'm going to get rid of the dividing by 1. We're going to say minus y equals sine theta. So when we do this, we are defining this as the positive direction of theta. So we're going to go, you know what, I'm going to change it. I don't want this to be the positive direction because of the way I drew the coordinate system. So instead, I'm just going to say y equals sine theta, and this will be a negative theta, and the the sign of a negative angle is negative. So this will end up being negative, but let's just keep it as sine theta, and we'll define this as a negative angle, and this as a positive angle. So going down from the x-axis is a negative angle, going up from the x-axis is a positive angle. All right, so we now know r hat is just equal to cosine theta x hat plus sine theta y hat. All right, what about r? R, we just know it's x sub p squared. X sub p squared. What's the y component? Plus d over 2 squared. Square root of that will be equal to r. Okay? Same exact equation we've seen over and over again. It's just you got to pick what is important, what elements in your drawing correspond to that. But when you look at this, you can see there's my r. There's my r. And what is that? You guys all know the Pythagorean theorem. Okay, so there's r. So what am I done? Well, yes, I am. Because now I know E plus is going to equal KQ over XP squared plus D over 2 squared cosine theta x hat plus sine theta y hat. Well, let's go ahead and look at the y component while we're at it. I'm sorry, not the y component, the negative charge component. So E minus, oops, all right, fine. E minus is going to equal minus KQ over XP squared plus D over 2 squared times cosine theta x plus sine theta y hat. I'm trying to think now if I define things properly, but it doesn't matter because we're going to take care of it. All right, so we have an E plus, A minus. What's our total? You just add them together. That's it. But what do we know about cosine theta and sine theta? Well, let's look at this triangle right here. Here's theta right here. So what is sine theta? D over 2 over x, over r is sine theta, and x sub p over r is equal to cosine theta. And so I'm just going to substitute those things in here. So this is going to be d over 2 over r. This is going to be, oops, sorry, did that wrong. D over 2 over r cosine theta. Oh, idiot. All right, x sub p over r for this one. Same thing here. X sub p over r. D over 2 over r, except for one thing. This d over 2 is either in the positive or the negative direction. So one of these is going to be positive, one of these is going to be positive, one of these is going to be negative. Just to be consistent with what I did before, I believe that puts this one negative. No. It puts this one negative. Okay. All right. So now all we're going to do is add those up. So what do we have? We have E plus E minus equals K Q. Yeah, we need to keep this in here. Over 1 over x sub p squared plus d over 2 squared. And once again, here's our favorite friend, the 3 halves. Yes, that's right. To the 3 halves. And then what do we have? We have a cosine theta minus, sorry. Since I did this, xp over r minus xp over r in the x hat. And we have this exact same term. I'm going to write it just on a lower line just because I'm running out of room that you guys can see. Same exact term out in front. I have this, and I'm going to have minus d. Actually, I have a same exact term except a minus sign in front of it. So I've got a minus sign there. I've got a minus d over 2 over r y hat plus d over 2 over r. Did I screw that up? Oh, yes. Okay. Yes, I did screw. Well, no, I didn't screw it up. I screwed it up with this right here. So let's keep that plus. Because what we're doing is we're taking one term from right here. We're taking this term right here. Yeah, we'll leave it. Yeah, so the minus shows up here. And then for this term here, the term we're getting from the E minus, that minus sign comes from there. So I have a minus d over 2 over r there in the y hat. So what I end up with is what happens here? This xp over r minus xp over r goes to 0. And minus d over 2 over r minus d over 2 over r goes to d minus d over r. And I take it back. We already took account of these r's in here. We already put the r in there. So we don't need this r. It's just minus d. Okay, so we have minus d. So we have E total is just the sum of E plus and E minus, and that equals minus K Q D over X sub P squared plus D over 2 squared to the 3 halves. Okay, and this is in the y hat direction. And does that, yeah, I think that's even right. I don't know. We'll see. Could be wrong by a minus sign, but that's the least of our troubles at the moment. So, okay, so this is what we have. And then the question is, what happens to this as x sub p is very large compared to d? Well, remember, this d is all by itself up here, or what I mean is there's nothing to compare it to. So if d is a small number, this whole thing will be small, but there's no big number there to offset it. So you can't ignore that. But down here in the denominator, x sub p is a very large number, d over 2 is a very small number in comparison, so when you square them, it's even less, and so what do you end up with? We end up that at far distances, this e sub t equals minus k q d over x sub p, I'm just going to do these exponents right here, x sub b cubed in the y hat direction. Okay, there we're done. Now, I did ask you one other thing. I asked you, what about here? What about way over at this point? So, what's going to happen at that point there? Well, what's theta? What's r hat? R hat here. If this is, let's go ahead. Well, yeah. I'll keep it like this. What's r hat? If this is our measurement point, we go from the charge to there. R hat is minus y hat, and that's it. No angle. So, what do we have? We have K, Q, over, let's see, I'm going to do E minus first. E minus first is minus KQ over, Y sub P now. Yeah, let's go ahead and do that. Y sub P minus D over 2 minus D over 2 squared. Okay? And this is Y hat. Alright, So that's what our E minus is. Our E plus is plus, oh, excuse me, didn't want to do that. I'm going to add this. We're going to have now plus KQ over Y sub P plus D over 2 squared in the, again, in the Y hat direction. And the question is, what happens to this as, let's see, I hope that's that, so I'm going to pull this over here just to make certain it's visible. So, the question is, what happens to this as Y sub P is large compared to D? We're going to do the same thing. We're going to say this is going to go to 0, excuse me, that goes to 0. So we have a Y sub P squared. So we have a minus KQ over Y sub P squared in the Y hat plus a KQ over Y sub P squared in the Y hat. And plus K sub Q Y sub P squared minus, excuse me, minus and plus are exactly equal. They cancel one another out. So the field and along the axis far from the dipole is, or far from these two charges, is equal to 0. Okay, that's that. And think about that and see if it makes sense to you. Okay.